Section 10-2, Part 1, Describing Sequences of Translations and Dilations. You are given that triangle ABC is similar to triangle NOP. ABC is the original triangle. It is similar to triangle NOP. By us knowing that these triangles are similar, we know they are the same shape but different sizes. As you can easily see, these two triangles, have the same shape, but they're definitely not the same size. NOP is much smaller than triangle ABC. So we are given that these two triangles are similar. They describe a sequence of rigid motion followed by a dilation with center 0, 0 that maps these two triangles together. So what we're going to determine is what steps do we need to take in order for us to map these two triangles together so that we can show that they are similar, all right? So the first thing we're going to do is we're going to think about, here we have this triangle, ABC. Here's our triangle. Now, how many units will I have to move the original triangle to the right and up in order so that B is lying on top of O, okay? So think about it. We're going to move this triangle. We're going to move it, shift it to the right, translate it to the right, and translate it up so that B is sitting on O. So we need to count over. I see that I need to move B to the right 2, so I'm going to go to the right 2. So if I move this triangle, think about it, if I move the triangle here to the right 2, 1, 2, then it's right there. Now I need to move it up to get to O. So let's see how many units I need to move it up. 1, 2, 3, 4. So I need to go to the right 2 and up 4. Okay? So I'm going to take this triangle. I'm going to take the given triangle here. All right? I'm going to move it to the right 2. 1, 2. Now I'm going up 4. 1, 2, 3, 4. And it will be lying on top of the smaller triangle. Okay? So let's look at this picture. This is where the original triangle was ABC, just like we talked about. The original is in black. Okay? The pink shows that I moved A to the right 2 and up 4 and made A prime. I moved B to the right 2 and up 4, and this is going to be B prime. And then I moved C to the right 2 and up 4, which is C prime. So here I had my triangle. I moved it to the right 2 and up 4. 1, 2, 3, 4. And now I have this triangle that's sitting on top of triangle NOP, which was my little triangle, NOP. So here I have my little triangle inside here, okay? All right, so at least we can see the mapping here. Right now, where this was translated to the right 2 and up 4, okay? So next, what we're going to do is we're going to have to determine the scale factor. What is the scale factor from going from the larger triangle to the smaller triangle? What was the scale factor, okay? So what we want to do is we want to take, for instance, let's take A prime. Let's take A prime. A prime's ordered pair would be to the left 2 and up 1, 2, 3, 4. Negative 2, 4. Okay? Now, when I look at this, looking at A prime pairs with N on the smaller triangle. What is the ordered pair for N? What is the ordered pair for N? N's ordered pairs to the left negative 1 and up 2. To the left negative 1 and up 2. Now, think about it. What would I have to multiply negative 2 times to give me negative 1? Well, think about it. What is the relationship of 2 and 1? 1 is half of 2. What is the relationship of 4 and 2? 2 is half of 4. So what happened here is we multiplied -2 times a half. We multiplied 4 times a half, okay? So when you multiply those straight across, you get -2 over 2, which would be -1, which is the ordered pair of n. Now if you take 4 times a half, 4 is over 1, multiply straight across, you get 4 over 2, which is 2. And therefore 2 is the ordered pair, the y coordinate of n. All right? So we found the scale factor that related the two triangles. It was a scale factor of a half, okay? Scale factor of a half. We saw that we had to multiply each one of A prime's ordered pair numbers times a half to get me to -1, 2, okay? So we could have also looked at this right here. Look at it. Think about, here's your smaller triangle, okay? And then here's your larger triangle. We could also draw them separately if we wanted to. Here's my smaller one. Here's my larger one, okay? What is the distance from O to P? From O to P, the distance was 2, okay? So from O to P, the distance is 2. Well, what is the distance from O to C? Well, that would be the same thing as B to C. What's my distance from B to C? I'm going back to the original problem. Let me show that again. The distance from O to P was 1, 2. The distance from B to C was 1, 2, 3, 4. So this distance was 4. So from here to here, the distance is 4. The full length is 4. The smaller length is 2. So you see, the larger triangle is twice as large as the smaller one. The smaller triangle is 1/2 the size of the larger one, okay? So, let's read about here. Yes, we have a scale factor of a half that relates the triangles. A sequence of a translation of 2 units to the right and 4 up, followed by a dilation, center 0, 0, scale 1/2, maps triangle ABC to triangle NOP. So triangle ABC maps to triangle NOP. Angle A corresponds with N, B corresponds to O, and C corresponds to P. This triangle has is half the size of the original, therefore their scale factor is 1/2.